Dear students, in this class we will discuss what is known as the distribution shapes. The distribution shapes. Now the distribution of a data set is a table, a graph, or a formula that provides the values of the observations and how often they occur. The distribution of a data set is a table, a graph, or a formula that provides the values of the observation and how often they occur. And so far we have described data sets by frequency distributions, relative frequency distributions, frequency histograms, relative frequency histograms, dot plots, stem and leaf diagrams, bar charts, etc. So these are all different ways of describing the data set in the form of a table, in the form of a graph, in the form of an equation, which will give us the nature of the data set. And for empirical analysis of data sets, the most important aspect of the distribution is its shape. Its shape. The shape of a distribution is very important for the empirical analysis, for statistical analysis of a data set. And the shape of the distribution plays a very important role in determining the appropriate method of data analysis. And suppose that you have a data set expressed in the form of a relative frequency distribution like this. Like this, relative frequency on the y-axis and say the variable under consideration on the x-axis. These are various classes, whether it is using limit grouping, cut point grouping, or a single value grouping, whatever it is. The easiest way to approximate the overall shape of the distribution is to draw a smooth curve like this. You draw a smooth curve like this to determine the shape of the distribution, whether it is quantitative data or qualitative data. In the case of qualitative data, you will not get such a distribution because the values are distinct. But you will get the shape more clearly in the case of quantitative data. And three important aspects of the shape are: one is modality, the second one is symmetry, and the third one is modality, symmetry, third one is skewness. If you draw a smooth curve like this on a distribution, relative frequency distribution or frequency distribution, you will get some idea about modality, symmetry, skewness, or you will get some idea about the shape of the distribution. And remember this, once we collect data for statistical analysis, we will arrange the data in the form of tables, in the form of graphs, to get a good idea about the shape of the distribution. And regarding the shape, these aspects are important. The first one is modality. Modality means the number of peaks. For example, the distribution is like this. The distribution is like this. Or the distribution is like this. Modality is related to the number of peaks. If the distribution has only one peak, it is unimodal. If the distribution has two peaks, it is bimodal. If it has more than two peaks, it is multimodal. So it is unimodal, it is bimodal, and it is multimodal. We will explain mode later. So that is modality. How many peaks? 1, 2, 3, etc. The second important aspect of the shape is symmetry. A distribution that can be divided into two pieces that are mirror images of one another is called symmetric. That are mirror images of one another. Consider this. It is bell-shaped. Consider this. Or consider a distribution like this. Now, this is bell-shaped. This is known as triangular, and this is uniform or rectangular. These are all specific categories of symmetric distribution. You can divide the distribution into two pieces. One piece is the mirror image of the other. Bell-shaped, triangular. They are also unimodal because only one peak. What about this? In the case of uniform distribution, we can think about the peak as infinitely large because all are peaks, or no peaks at all, depending on how you view it. So that is symmetry. The third one is skewness. A unimodal distribution which is not symmetric is either right skewed or left skewed. A unimodal distribution which is not symmetric is either right skewed or left skewed. This is right skewed, this is left skewed. Right skewed, left skewed. Unimodal, not symmetric. A right skewed distribution rises to the peak rapidly and comes back to the horizontal axis slowly. Rises to peak quickly, come back to horizontal axis slowly. So its right tail is longer than the left tail. This is the left tail, this is the right tail. A left skewed distribution rises to peak slowly but come back to the horizontal axis quickly. So its left tail is longer than its right tail. And this is skewness. Measures of skewness will be considered later. And remember this, in statistical analysis, the shape of the distribution is very important. Whether it is normal, skewed, if skewed, right skewed or left skewed, symmetric, all these shapes are important for statistical analysis, which we will discuss later. And one more point is, when we talk about the distribution, we always make a distinction between population and sample distributions. Population, if you have population data, that is, if you have the values for the entire population, then we have what is known as a distribution of the population distribution. If you have only a sample, you have a distribution for the sample, so sample distribution. So in the context of distribution, whether your data is population data or sample data, we talk about a population distribution and a sample distribution. And remember this, there is only one population distribution because there is only one population. For example, if you take the height of the population, there is only one distribution because there is only one population. But since you can take any number of samples from the population, there will be infinite number of sample distribution. Infinite number of sample distribution or many sample distributions. Only one population distribution, many sample distributions. And remember this, to get the population distribution, the entire population will be available to you. But in most cases, the population is either unknown or very difficult to collect. So what we have is only a sample distribution. And the sample distribution is used to make inferences about population distribution. And that is the essence of inferential statistics. So in inferential statistics, we use sample distribution to make inferences about population distribution. Sample distribution or sample characteristics, we will explain later, are used to make inferences about population characteristics. Its shape, its distribution, or some of the quantities, some of the parameters that we will see. What is a parameter later? So remember this, sample distribution is used for making inferences about population distributions. So the distribution is important. Its shape is important. So one must have an idea about the shape of the population distribution. And only sample distribution can be used to make inferences about population distribution.